I had a request to do example number 82 from section 2.1, and so I thought I would just share that with everybody. And so what we have is this figure here. I did my best to draw it. I'm kind of chuckling because it doesn't look so great, but it is the correct translation of what's there in section 2.1, number 82. And our job is to find all the missing variables. And so we need to know what A is and what N is, I apologize, this one down here is an M as in mouse. So there's an N, an M, an A, and a Q. And a 7 hanging out, as well as some degrees that we know. So they want us to remember that if you have right triangles, well, trig can really help us out. We can find all those missing sides. Let's go find them. Let's focus on A first. So if we want to find A, I'll just put find A. We are going to set up a trig relationship that involves A. So I'm going to look at the triangle that's on the right hand side. I'll go ahead and highlight that in yellow, but I'm going to consider this triangle right here first. That's going to help me get A and then also M. I might as well get both of those sides from it. How am I going to do that? Easy. I'm going to use the fact that the sine of 60 degrees is opposite 7 over hypotenuse A. That involves numbers that I know, only one of which I don't know, right? So it has three spaces, sine 60, 7, and A. Only one's a variable. Sine 60, we know that, root 3 over 2. Ideally by memorization is equal to 7 over A. You can choose whatever method that you want to solve this ratio that we've had since our early days of even arithmetic. And we'll just do a root 3 is equal to 7 times 2, right? Multiplying through the cross multiplication. And so that's a root 3 is equal to 14. And all we have to do to find a is divide both sides by root 3. Now you and I remember that we can't leave a root 3 on there, so they're not going to have that in the back of the book. They're going to have 14 root 3 over 3 as we rationalize it. That's how we find A. So now we've accomplished 1/4 of our goal. If we're going to find B, oh sorry, not B, there is no B, find M. I'm going to stick in the same triangle and look at not sine of 60. Personally, I would totally use the 7 again. That was the number that was given to us. I avoid at all costs using numbers that I figured out. So I'm going to go look at the tangent. So this is to find M. I'm going to go look at the tangent of 60 degrees. Now, why did I choose tangent? Because I know tangent is opposite over adjacent. And what's the tangent of 60 degrees? Well, I think you know that the tangent of 60 degrees is square root of 3 is equal to 7 over M. And so that means m root 3 is equal to 7, or that m is equal to 7 over root 3. And multiplying top and bottom by root 3, we get 7 root 3 over 3. So that's how you find m, and we get a nice 7 root 3 over 3. So I'm just going to write what we found out along the side here. We found out that a was equal to 14 root 3 over 3. That'll be useful. We found out that m is equal to 7 root 3 over 3, right? If we take a look down there. So I'm going to erase all this work so that we can always have the picture in mind. Now we know what we're doing. We're using trig functions to provide meaningful relationships, ideally with only one variable in it. Then we can solve it. And so as we come back up here, we found A, we found M, we're halfway done. And now we need to find, let's go ahead and find Q. Okay, so if I go to find Q, what I have for Q is, maybe I'll use the fact that the sine of 45 degrees is the opposite, A, but I know what A is, 14 root 3 over 3 over the hypotenuse, which is Q. I know the sine of 45 degrees is square root of 2 over 2. And so I have a little bit of a mess. But we know that you understand algebra. And so you know what I'm going to do is I'm going to get rid of this Q. by multiplying both sides by q. May not be what you have decided to do, but now I have root 2 over 2q is equal to 14 root 3 over 3. So I can, and let me go in a different color, I can multiply by the reciprocal. And again, there's lots of different ways to do this algebra. The challenge will be to just pick one that you feel comfortable with. So I've solved for q. I got q all by itself. Now I just got to clean up this other side. So I get 28 root 3. 14 times 2 is 28, and the root 3 just goes along for the ride. And 3 times root 2. You and I know that we can't leave the root 2, so we're going to rationalize it and get 28 root 6 all over root 2 times root 2 is 2 times 3 is 6. And they'll bring that down to 14 root 6 over 3. So now we know our q is 14 root 6 over 3. So a little bit of effort here, but they just want you to realize the power of knowing the trig functions, especially if you have a right triangle. Then the last one to find is n. And so let me find n again so that I can keep that picture up here. I'm going to erase what we did for q. I've noted q off on the side in case we need it. I don't think we will though. If we want to find q, maybe we use, I'm sorry, we found q. Now we're finding n. It's going to say, hey, we got q. So we're going to find n. That's the last one for us. And if we're going to find n, maybe I use the tangent again. Tangent of 45 degrees is opposite a, which we know is 14 root 3 over 3, over adjacent, which is n. Tangent of 45 degrees is 1. So 1 is equal to 14 root 3 over 3 all over n. I'll do the same thing that I did last time. I'll multiply this side by n and this side by n, and then I'll be done. N all by itself, these n's cancel, is equal to 14 root 3 over 3. There's at least one person out there that's screaming at me saying, Jensen, you're wasting your time. You know that if it's a 45-degree angle, it's an isosceles triangle, and A and N are equal to one another. Those are the equal sides. And so it doesn't look like it in my picture, but those should be equal sides because of the 45-degree angle, and therefore both 14 root 3 over 3. So we're not shocked at that at all if you know those relationships. But the point is you didn't have to. You can use trig to answer everything. Hopefully that helps.